Here is the first lesson of the third curriculum. We are going to present a method for conducting welfare analysis. Before starting the welfare analysis, I would like to do a few remarks. First of all, in the model that we built incrementally and that we calibrated on fictitious data, I just made a change in the data. The tariff data was changed because the tariff structure was really uncommon. There was no tariff in agriculture and services, only a tariff in industry, and this tariff was very high at 77%. So a shock of tariff liberalization could be interpreted with this tariff structure, but it was very, very specific. To teach how to interpret a shock of tariff liberalization, I thought it would be better to start with a more ordinary situation. In the new fictitious economy, tariffs are 30% in agriculture, 12% and 11% in industry and services. This is a situation which is much more representative of emerging and developing economies. Then I made a small modification in the model. I added an equation and an unknown variable. This unknown variable is a consumption price index. It is a variable denoted PINDC. And the equation is the formula of this consumption price index. So the numeraire is no longer the domestic price of the local agricultural good, but a consumer price index. Many modelers adopt this solution. Indeed, why take one good rather than another as the numeraire? By using a price index as a numeraire, one protects oneself against the criticism of an arbitrary choice of good. Let us note that this price index is calculated according to the Fisher formula, that is to say, a geometric average of a Lasper index and a Pasch index. You can do a little bibliographic research if you have trouble remembering those index problems. So the instruction pd.fx_agr equal to pd0agr is removed, and it is replaced by the instruction pindc.fx is equal to pindc0. So the central issue here is to measure the impact of a reform. When you run a CGA model, often you compare several reforms, several political decisions. How can we compare them on the basis of a single criterion? A criterion which can tell us which reform is the best. As you can see, we are dealing with a very important issue here. One could say the key issue is to measure the impact on macroeconomic activity. Gross domestic product, GDP, could then be used as the metric of the reform. Concerning unemployment, we could also use the level of unemployment in the economy. This consideration will be introduced later. Today, we do not have any unemployment in the model. A look at gross domestic product, or GDP, can be complemented by a look at sectoral variables like sectoral value added or sectoral employment. But economists generally think that it is more important to look at the impact on economic agents. And so since we have here a representative agent, we will look at the impact on this representative agent. So what we can do is to look at the impact of a reform on the consumption of each good by the representative agent. When considering the consumption in volume of each good by the representative agent, we meet several problems. First problem, there are several goods, and we need one metric, not several. This is a more technical problem. We can solve it, for example, by constructing an index of the volumes consumed. Second problem, which is more important, satisfaction is not proportional to consumption. Generally, the satisfaction or the welfare derived from the consumption of a good increases with the volumes consumed, but marginally less and less. Putting differently, marginal utility is positive but decreasing. Therefore, there is a saturation effect. You could tell me, why not take the utility function as the metric of a reform to measure its impact on agent? In fact, utility function is not directly usable. Indeed, the utility functions constructed by economists for describing consumers are based on an ordinal theory of preferences, not a cardinal theory of preferences. Thus, these functions give us just an order of comparison, not a direct metric of satisfaction, of well-being. With a utility function, we can compare ordinally two options, but not cardinally. If a utility function assigns twice as much utility to one basket of consumption compared to another, we can just say the first gives more well-being than the second, but not that it gives twice as much well-being. To measure well-being, Sir John Hicks invented the concept of equivalent variation and compensating variation. The concept of equivalent variation will be explained here. To explain John Hicks' equivalent variation, which will give us a monetary metric of welfare, I present here a simple example. Here, the utility of an agent depends only on the consumption of two goods, 1 and 2. The agent's income is R, the prices are P1 and P2. And I suppose that P2 is equal to 1. So as the maximum consumption in volume that this agent can have of each good is R over P1 and R over P2, we know that R over P1 is the x-intercept of the budget line and R is its y-intercept. Initially, in red, with this budget line and indifferent curves, U, the optimal choice of the consumer is A, which allows him to reach the utility U0. Suppose that the price of good 1 drops from P1 to P'1, the new budget line is in green. With the lower price of good 1, the representative agent could increase her or his consumption of good 1 if he allocated all his income to the consumption of this good. The new optimal choice is B, which gives the agent a utility of U1. The equivalent variation of John Hicks is EV on this new chart. EV is near the vertical axis, almost at the top of this axis. We can say that EV is the measure of the gain in welfare that the fall in the price of good 1 from P1 to P'1 gives. We have a new budget line, the blue line, which corresponds to a total budget of R plus EV. And with this budget line, the consumer reaches his maximum utility in C, which gives him a utility of U1. How can we understand this? I would make two important remarks here. The blue line is parallel to the red line. You know what the slope of a budget line is. It is the ratio of prices. So with the blue budget line, the prices are the same as in the situation the agent was initially in, a situation which is described by the red line. Second remark, the optimal choice C is on the same utility curve as the optimal choice B. So in both situations, the consumer has the same welfare. So we can say EV is the supplement of income, such that the consumer is indifferent between a situation where he has this income R plus EV and faces the initial prices, and a situation where he has an R income and faces the final prices. I repeat, EV is the supplement of income such that the consumer is indifferent between first a situation where he has this income R plus EV and faces the initial prices, and a situation where he has an income R and faces the final prices. So EV is a monetary measure of the welfare gain that the representative agent derives from the price decline. The problem we are now asking ourselves is, how do we calculate this equivalent variation? There are several directions that we can take. Point C corresponds to a utility maximization for initial prices. We know how to run a utility maximization program. And we know the initial prices and the final level of utility. So the solution is, in fact, relatively simple. We have to run the utility maximization program by imposing two constraints. The prices are equal to the initial prices, and the utility is equal to the final utility. We define a new model from only two equations, EQ underscore C, which is the solutions of the utility maximization program and the budgetary constraint, and gives us the level of consumption, and then the equation EQ underscore U, which defines the utility level. So how do we do a welfare analysis? First, I record in a new parameter the final value of the utility, U underscore final is equal to U dot L. I remind you that U dot L is the current level of the utility. As we write this instruction after running the model with the shock, U dot L is the final level of utility. Then I impose two constraints, P dot Fx in sector I is equal to P0 in sector I. So the consumption prices are fixed at the initial level of these prices. And U dot Fx is equal to U underscore final. So the utility of the representative agent is fixed at its final level. So I have a new model defined by the instruction model EV, which is the new title of the model, or the title of the new model. And this new model is defined by two equations, EQ underscore C and EQ underscore U. This new model has four equations, three equations EQ underscore CI, and one equation EQ underscore U. And it has four endogenous variables, CI and disp underscore INC. Indeed, if you look at these two equations, you have P in sector I, which is fixed, C, Mi, IN, gamma, and MPS, which are parameters. And so the only endogenous variables are C in sector I and disp underscore INC. So I write the instruction solve EV using CNS. So it's going to look for solution of these two equations, trying to solve for CI and disp underscore INC, with P in sector I and U, the utility, fixed at respectively initial and final level. And so it gives me value for consumption CI and a new value of disposable income, which is the initial value of disposable income plus the equivalent variation. And so knowing this new value of disp underscore INC, I can derive the equivalent variation by the instruction EV or EQ U underscore VAR for the equivalent variation is the current level of disp underscore INC dot L minus the initial level of this variable disp underscore INC 0. I would like to make a few remarks here, and these remarks are indeed very important. The welfare of the representative agent only depends here on her or his final consumption of private goods. However, the provisions of public goods may have been modified. And we know that with unchanged disposable income and prices, agents are not as satisfied in an economy with less public goods. So if public revenues decreases, and if this implies less public expenses, it may lead to less public goods, and it might hurt the representative agent's welfare. So we must be very careful when we conduct a welfare analysis and when we consider the consumption of only private goods. We have to be careful and have a look at the level of public goods in the economy. So here is the assignment. I would like you to use the C3M1V1 students.gms model. And with this model, I would like you to make several things. First, have a look at the new equations of consumer price index. You know that this index now is the numeraire of the model. Then I would like you to apply a cancellation of all import duty, that is to say a trade liberalization. And I would like you to interpret the result on a one-page document. In particular, I would like you to have a look at the welfare impact on the representative agent. I have in fact inserted in the model instruction to calculate equivalent variation. But what is not inserted in the model is the impact on the degree of openness of the economy. So I would like you to calculate this degree of openness. The definitions is exports plus imports divided by 2 over the gross domestic product. And I would like also you to calculate the compensating variation of X in percentage. So you have first to make some bibliographic research and then to implement new instruction to calculate compensating variation.